Hey gang, we are going to make this function differentiable everywhere. We're going to find A and B. So there's two big steps we have to do. The first thing we have to do is we have to make sure that the function is continuous. And remember, there's three conditions for continuity. The point exists, the two-sided limit exists, and the point equals the two-sided limit. So I'm starting in that arena. So a little less than 2 is this guy. If I plug in 2 for x, I'm just going to write it as 8a versus a8. Okay, let me just hold on that guy for a second. And then 2 from the right would be this function. Oh, sorry, hold on one second. It's always nice when I catch myself and don't have to redo the video. You guys are always good at pointing it out on the board when I make a typo, and okay, all right, so again, the three conditions for continuity, but let me leave that part there for a second. Now notice when I do this, I'm actually doing the limit of the derivatives, So the derivative function, if you take the derivative of this would be the power rule. The 3 would come down in front, so it'd be 3ax cubed. Did you catch that? The 3 comes down in front. This is already a constant, so if we knew what this was, it would multiply together. You subtract 1 from the exponent. All right, the derivative of this is 2x. B is a constant. So the derivative of a constant goes to 0. Alright, so now we're going to work on that part. Because for it to be differentiable, it must be continuous, but then the derivatives also have to approach each other, right? You can't have a gap, you can't have a point, you can't have anything like that. It's got to be like a continuum, almost like parabolic looking. Alright, so now I'm plugging it into the derivatives. Alright, 3 times 4 is 12. Hold on a second. Did I? No, I got it. Okay. Alright, now these have to be equal just like these have to be equal. Alright, so here we go. So remember, the limits have to be equal. The limits of the two-sided limits of the function have to be equal, and the two-sided limits of the derivatives have to be equal. So 4 plus b has to equal to 8a, and 12a has to equal to 4. So those are the two equations that we're getting. And this is why it's important that you get two equations. So if you recall, if you have two unknowns, you need two equations to solve. So I now have enough information to solve this. You're going to start over here and find the A. And then once you know the A, you're going to come over here and you're going to solve for the B. So now I plug this in here. And I've squished myself into a corner. Just moving the 4 to the other side. Okay, let me just move this over to here because I will forget it in 2 seconds. Alright, so let's do it. Let me see if I can find something fancy over here. Maybe this guy will work. So A is going to end up being 1/3. And B is going to end up being -4/3. So now you have a function that is differentiable everywhere. It satisfies the condition for continuity, and it satisfies the condition for differentiability because the limits from each side approach each other, so it will indeed be that value when you at 2. All right. Alright, gang. I hope that helps. I'll catch you. Bye-bye.